Welcome to digital class students. This is the last session of 10th class chapter sets. So today we'll discuss some of the important problems in these sets. These problems are very important and examination point of view, these are important. So mainly the knowledge of the real numbers is very essential while converting a set builder form into a roster form. Like natural numbers starts from the number 1, and the whole numbers are denoted with an alphabet W, and they start from the number 0. Integers are the negative integers, positive integers, and 0. So the integers are denoted with an alphabet Z. Even numbers are, these are the even numbers, the numbers which will come in two table. The odd numbers, the numbers which are not even or odd numbers, prime numbers. So the numbers which has factors 1 and the number itself are prime numbers. The composite numbers means the numbers which are not prime numbers are composite numbers. Perfect square numbers. So these are the perfect square numbers. So these number can be written in square form, like 4 can be written as 2 square, 9 can be written as 3 square, 16 can be written as 4 square, 25, 5 square, and so on. Perfect cubic numbers. So these numbers can be written in a cubical form, like 8 can be written as 2 cube, 27 can be written as a 3 cube, and 64 can be written as 4 cube, and 125 as 5 cube, and so on. So the knowledge of these numbers is very essential while solving problems like converting set builder form into a roster form. So this knowledge is very essential, and in the examination they may ask for 4 marks questions, like convert any set builder form into roster form, and you have to perform some basic operations also. So like the factors and multiples knowledge is also very important. Actually, the factors concept will be introduced at class 4 or 5. So factors for 24. So the 24 will come in which tables, like 124 can be written 124 is a 24, 2 12 is a 24, and 3 8 is a 24, 4 6 is a 24, and 6 4 is a 24. When you closely observe, the 4 into 6 is reversed like 6 into 4. Now you can reverse the other numbers also, like here, see here, like 4 into 6 can be written as 6 into 4, and 3 into 8 can be written as 8 into 3, and 2 12s can be written as 12 into 2, and 1 into 24 can be written as 24 into 1. Therefore, the factors will be the numbers which are inscribed in the box. Like these are the factors for 24. So you may ask a question like convert right factors for some number, and that factor should be less than or more than or equal to in roster form, and basing on that the problems may be asked. So this knowledge is also essential. Multiples of 4, these are the multiples of 4. Multiples of 4 are nothing but the 4 table. You can write like this. So this is an infinite set, and the multiples are, so the numbers which are inscribed in the box, like 4 8 12 16 20 24 28 32, and so on. These are the multiples of 4. So this knowledge is very essential. Now we'll take one problem. This is a 4 marks question. Look at the problem, how they have asked. So the set A is given, which is an a set builder form, x such that x is equal to 8m plus 1, where m is a w. W means you have to know the y, which with what number the w is represented. Like w is represented as a whole number, and the number starts from 0. So that knowledge is essential while solving this problem. And x is less than 50. And B set is also given in a set builder form, x such that x is a perfect square number. So look at this here, the perfect square number. You should have the knowledge of this also. And the x is less than 40, and x belongs to n, that is a natural number. And you have to perform these operations. So when if you are able to write this set builder form into a roster form, then it will be more easy, and you can easily solve all these basic operations. See here, now we'll solve. So M is W, that is, it is a whole number. Whole number means the numbers will start from 0. And this is an infinite set. So it is given that x is equal to 8m plus 1. In place of m, we have to substitute each and every number. Now in this position, in this step, we'll substitute 0. We'll get 8 zeros, 0 plus 1, that is equal to 1. And next we'll move on to, now we'll substitute 1. So 8 ones are in place of 0. I've substituted, I've taken the second number, that is 1. 8 ones are 8. 8 plus 1, that is equal to 9. And now here 8 twos are 16. 16 plus 1, it is 17. Next 8 threes are 24 plus 1, it is 25. And like this, so on, like this. And this should be, x should be, it should be less than 50. So x should be less than 50. So when you substitute 6, 8 6 are 48 plus 1, it is 49. So when you take 7 in place of 6, you will get the answer which is more than 50. So we have to cut till here. We have to take the numbers till here only. That is, so now we can write the set A like this. So this is set A, the numbers which should be less than 50, right? Next, we'll write the set B also. Set B, what is given? X such that x is a perfect square number, and the x should be less than 40, and x is a natural number. So you know the perfect square numbers are, these are the perfect square numbers. When you take 7 square, 7 sevens are 49. So 49, which is bigger than 40. So we have to take till 40. Therefore, we have to cut till 6 square, that is 6, 6, 36, like this. This is set B. And now you know the set A and the set B, which are written in a roster form. Now you have 2 sets. Now you can easily perform these operations. A union B, like A union B, is the numbers which are in A or B, like 1, 4, 9, 16. So these numbers are in set A or set B. So we have to write in an ascending order neatly. Now A intersection B. So these two are the set A intersection set B. Intersection means the common elements. Therefore, 1, 9, and 25 are the common elements which are in both A and B. So these are the common elements. So A intersection B, you can easily write A minus B. This is the set A minus the set B. When you subtract set B from set A, first we have to identify the common elements, and we'll remove the elements, and the remaining elements in set A will be the A minus B. Now B minus A is set B minus set A. Now again identify the common elements, remove them, and the remaining elements in set B will be B minus A set. So this is A minus B and B minus A. Now we'll do one problem here. See here. This is an important 2 marks question. A minus B is given, B minus A is given, and A intersection B is 5, which is a null set, and draw the Venn diagram for this. So for this Venn diagram, so where we have to write these elements in the sets, in which portions we have to mention these elements, I'll show slowly. See here, it is given that A intersection B is 5, means it is a null set. So where is the A intersection B part? Can you locate it? Yes, this is the A intersection B. So in A intersection B part, there is no element. So it is plain like this. Now A minus B portion. So which one is A minus B portion? So this one is A minus B portion. So in this A minus B, what are the elements are there? 1, 2, and 3. And what is the B minus A portion? So this one is B minus A portion. So what are the elements which are there in B minus A? How many? What are the elements? They are 8, 9, and 10. So like this, you can draw a Venn diagram very easily. This is a 2 marks question you may get for the final examination. Now, write subsets for a set is given, and how to write subsets for these sets. So you can write like this. These are the subsets. See here, how many subsets are there? 1, 2, 3, 4, 5, 6, 7 subsets are there. So without writing also, we can directly find out how many subsets can be written. There is a formula, like we can write 2 to the power of n minus 1, where n is a cardinal number of the set. Like, so the number of sets can be, number of subsets can be find out with the formula, this one, 2 to the power of n minus 1, where n is a cardinal number. So here, the elements in set A are 3. So 2 to the power of 3 minus 1, that is 8 minus 1, 7. Therefore, 7 subsets can be written. See, this is 1, 2, 3, 4, 5, 6, and 7. So the number of subsets will be 2 to the power of 3 minus 1, that is equal to 8 minus 1, that is equal to 7 subsets. So without writing the subsets also, we can find out the number of subsets which can be written from a set. So this is for clarification and verification also. You can use this formula. This formula is not there in the textbook. So this is, you have to remember. And this is all about sets. Thank you, children. Thank you for listening, for watching my videos. If you have any doubt, you can put in the comment box. And all the best. Keep watching my channel, and you share and subscribe the channel also. Thank you.